This is part 2 of types of chemical reactions. In this video, we'll go over the single replacement reaction and the double replacement reaction. In a single replacement reaction, an element takes the place of another element that is part of a compound. Here's an example. Zinc, which is a metal, plus hydrochloric acid will form zinc chloride and hydrogen gas. So zinc takes the place of the hydrogen. That's why it's called a replacement reaction. It bonds with the chlorine to form zinc chloride. Since the hydrogen was bumped out, it is on its own in the product as a single element. This video demonstrates the reaction of zinc and hydrochloric acid. You could see the bubbles of hydrogen gas forming as the zinc reacted with the hydrochloric acid to form zinc chloride. This reaction can be shown with a cartoon analogy of kids at a dance. And in this case, we have a single person joining their friends who are dancing. The single person dances with one of the friends, but that leaves the other friend alone. Just like how the zinc replaced the ion hydrogen, leaving the hydrogen on its own. In a single replacement reaction, a more reactive element can replace a less reactive one from a compound. However, the opposite reaction does not occur. Here's an example of copper plus silver nitrate forming silver plus copper nitrate. The copper and silver ions switch places. Let's watch a video about this reaction.
In this example, we're going to combine a strip of metallic copper with silver nitrate. That's dissolved in solution. You'll notice that the surface of the copper that's immersed in silver nitrate is starting to plate silver metal. And at the far end, where the copper color is preserved, that piece of the copper strip is above the silver nitrate. After several minutes, it's clear that copper nitrate has been produced and is released into solution, and the strip of metallic copper now is covered with metallic silver. In this reaction, we took copper metal and we placed it into a solution of silver nitrate. A reaction began immediately, and in the process, copper metal replaced the silver ion. The products of the reaction then were silver metal, which we saw form on the strip, and copper 2 nitrate. Copper 2 nitrate was responsible for making the solution turn a blue color. This equation isn't balanced because we have 2 nitrate ions on the product side and only 1 nitrate ion on the reactant side in silver nitrate. We'll put a 2 in front of the silver nitrate to balance the nitrate ions. In the process of balancing the nitrate ions, we also generated 2 silver ions, and they'll be balanced by putting a 2 in front of the silver metal. And this equation is now balanced.
Let's review. In a single replacement reaction, the general formula is A plus BC yields AC plus B. We start with an element and compound and end up with a different element and different compound. You'll always see 2 reactants forming 2 products, but in each case, there's a lone element on each side of the chemical equation. The next type of reaction is called a double replacement reaction. A double replacement reaction is a reaction in which ions in 2 compounds switch places. One of the products of this reaction is often a gas or a precipitate. For example, sodium chloride plus silver fluoride will form sodium fluoride plus silver chloride. In our cartoon analogy, we have 2 couples at the beginning, which represent the 2 compounds in our equation. But over the course of the reaction, the couples switch partners and are dancing with the other friends. So now that represents the 2 new compounds that are formed when the ions switch places. If you look closely, you can see that sodium and silver are the ions that have switched places in the reaction. Here's another double replacement reaction. Lead nitrate and potassium iodide will form lead iodide and potassium nitrate. The lead and the potassium will switch places. Here is a video about this reaction.
Hey everyone! Today's video is a very cool experiment that's a pretty common demo in chemistry classes called the Golden Rain. And this is going to be a combination of potassium iodide solution and lead nitrate solution. Quick word of warning, lead and all of its salts, especially its soluble salts like lead nitrate, are extremely toxic. So you really need to be extremely careful when you're handling these, and really you shouldn't handle them at all unless you're an experienced chemist.
We'll skip ahead in the video to show the reaction when he pours the sodium nitrate into the potassium iodide solution.
Let's take all the rest of the potassium iodide and add it directly to it. This should be pretty cool.
You can see that a solid yellow precipitate has formed. Later in the video, he heats up the new solution until all of the lead iodide has dissolved, and then he lets it cool down. Let's see what happens as it cools. Let's review. In a double replacement reaction, the general formula is AB plus CD yields CB plus AD. The ions have switched places. We always start with two compounds and end up with two compounds in a double replacement reaction.